Hi, welcome to Linux channel. So usually you see me covering specific topics per episode, but this is the first time. As you can see in the title, I thought let me cover an entire course about OpenWRT so that I can cover as many aspects as possible in topic wise. So in case if you are already working in OpenWRT or you are very new, you want to go through, you can go through from the beginning, or if you are already into OpenWRT, you can choose a specific topic. I'm going to add this video timestamps so that you can watch those relevant topics in case you want to refer something. If you are a student, you may never heard OpenWRT because it is something quite prevalent in the industry, but it is not something a beginner will ever know that such a thing is there. So those who are wondering what is OpenWRT is a sort of trimmed down Linux embedded OS distribution meant for all these routers. So basically you are buying any Wi-Fi router in the market in Amazon, chances are 99% it may have some sort of customized OpenWRT. So what they will do is they will take that router hardware, a custom router hardware. Let's say you bought some TP-Link or D-Link router or even Netgear or something like that. So you buy a Wi-Fi router, it will have a entire customized ported OpenWRT on that. Along with that, it will have certain proprietary automation on top. Say for example, you bought some TP-Link router, it may have a TP-Link UI entirely done by TP-Link, but within that within its guts it will have OpenWRT. The entire automation, everything is nothing but OpenWRT. So again, in case you are wondering why there is OpenWRT, there are other options available. The whole objective is when we go to the market, when we want to build a custom router, you can use even Ubuntu or any other Linux distribution. End of the day, kernel is what does the routing, because these cheap routers, the data plane is in the Linux kernel space. As I discussed in various episodes, in case you are not understanding what it is, I will give a quick intro of that. See, there is something called data plane and control plane. Of course, there are more planes in network device architecture. So where the packets gets processed, where the packets are pulled and then it gets processed and it gets sent out of that drivers is what we call it as data plane. So in the networking subsystem of Linux kernel, the packets will arrive from the device drivers. It can be any hardware port, let it be Wi-Fi or let it be wired port, let it be whatever architecture, even it can be a Bluetooth also. So in case if it is a networking via any of this hardware architecture, so the packet will comes into the kernel space via drivers, then it will go through the networking subsystem. Based on the packet type, etc., it will go to different networking stack. For example, a typical IPv4 packets will arrive inside IPv4 stack. They get processed. If they are meant to route, then it will go through that process, or if it is meant for local device, it will be pulled up all the way as a part of sockets framework. Okay, so this is what happens. So in a case of cheap routers versus expensive enterprise routers, the data plane is in the Linux kernel space. The packets will come into the Linux kernel, they get processed and they will be sent. So such is the architecture of most Wi-Fi routers you buy in the market. So for example, we take any router here, let's go to Amazon, say Wi-Fi router. It doesn't matter which brand you buy, it's what the industry standard is. You can see here TP-Link and there is something like D-Link, etc., etc. So all these routers, 99% they have customized OpenWRT. So hence OpenWRT is a completely trimmed down embedded Linux distribution. It will contain the Linux kernel as usual, and then it will contain various user space automation, so that the configuration of these networking components are completely streamlined, unlike something like Ubuntu's desktop or Ubuntu server. I'm not saying Ubuntu alone, it can be anything. It can be even CentOS or Red Hat Enterprise Linux or anything like that. See there, if you go there, say for example you want to configure Wi-Fi, then you need to install some tools like HostAPD, etc., and then you need to configure the Wi-Fi. Similarly, you want to bring up some LTE drivers. Okay, for example, you want to put some sort of SIM card inside the router. See, for example, if you search Wi-Fi router SIM card capable, there are some routers you can see here, they have a SIM card slot. Then in that case you need to install those packages in the user space to enable that port. Similarly, it may be something like you want to enable a DHCP service, then you need to install the DHCP server, configure the same in etc, and you need to do all those things, which is not needed in case you have the OpenWRT router OS. See, for example, this is one way of doing it. There are other ways also you can accomplish. You can also use something like pfSense, but the more emphasis here given towards firewall feature of it. So this also works like OpenWRT. Besides, it does this extensive firewalling and stuff. And moreover, pfSense is based on FreeBSD versus OpenWRT is based on Linux, and the kernel is Linux, but the entire user space, it has an entire custom architecture called UCI, LuCI Interface and stuff like that. So it's a complete different world by itself. Hence, if you join a company, in case they don't have resources, they will expect you to learn OpenWRT. Either they can train you within the company by senior staff, or they may send you some towards some institute, or they may ask you to self-learn if they are not having enough resources or budget. But the objective of this video is so that I can cover all the aspects of OpenWRT as much as possible, so that you can just watch this single video and then you get the entire big picture and the practical way of approaching the OpenWRT Linux distribution. You can call it as operating system in general, so we can call it as operating system. As you know, in Linux world, it's better to call it as a distribution rather than a specific operating system, because the word OS itself is just kernel alone. Hence, the distribution is what defines the thing which contains kernel and all the packages and everything put together, so that you can use it in the practical world. So that way you can see here. You can go to the OpenWRT website. You can find its releases and lots of things which are discussed there. There is also a discussion forum. It loads slowly, after that it works fine actually. So literally OpenWRT is available for any known architecture, let it be MediaTek processors, ARM processors, Raspberry Pi, or it can be any other architecture. Hence I am saying it is widely ported embedded Linux operating system, which is meant to make any device into a proper router. See, in that case, what I did is, sometime recently I bought this Dell device you can see here. So this is something I bought in Amazon. You can see in my old orders. So sometime around March I bought this. This is a Dell Optiplex 7040. This one is although I ordered for 7040, what I received is 7050. Yeah, it is 7050. Later I am going to do close shots of this, so that you can have a look of its hardware architecture or hardware components and stuff. Okay, so this is what I ordered. I ordered for 7040. You can see here it comes with 8 GB RAM and 256 GB SSD. So these are refurbished devices. So where you can find these devices are usually if you go to any hospital or somewhere, you can find something like this used by those receptionists and all. So this is a very tiny PC. The objective of me buying this is not to build an OpenWRT router, but instead I want to use this as my tiny everyday workhorse, rather than using this large PC over here. You can see here. So this PC you must have seen in many episodes from many years after I started the Linux channel. Almost the time I started Linux channel is when I bought this PC newly at that point of time. So it's quite old, but it is extremely powerful, but not always I can use that. At the same time, I don't like much using laptops, because something I need to change, I need to upgrade, it's not that easy. And since I use Linux, I don't need even a beefier system for everyday use. In this system, believe me, you can run a couple of VMs, and you can run a fair amount of apps all together. I will be using 3-4 browsers together, each browser around 5-6 tabs open, and a VM most of the times it will be running inside it. So this is my workflow, and this is the load I put, but still it kind of manages to work fine. Okay, so this is what I have. You can see here it's a refurbished device. You get like this many in Amazon. You can see, and you can buy yourself if you are looking for something like this. I am going to share those links. So you can see here its price is more or less the same. When I purchased, it's around 9,000 or something. At the time there is some offer, so it is like that. Moreover, in case you have any upgrade, you can also think about buying an upgraded version. Okay, if it is 7050, assume you have 7060 or something like that, you can buy. I am lucky I got actually an upgrade for the same price of this 7040. So I am very happy with this purchase. So this came with 8 GB RAM. Since I am using more like a laptop substitute, I upgraded with another 8 GB RAM, and moreover, since I use VMs on it, I just felt a little more RAM is going to help me. So hence I have upgraded this hardware specs. But now, considering about OpenWRT device, trust me, if you install OpenWRT and start using it, this will work as same as any other home based router. And you can see its ports in the back side. This came with already Wi-Fi module. Again, I am going to do close shots of that hardware specs, etc. So this came with a Wi-Fi module, and you can see here I connected this antenna, and this came with a single you can see a single Ethernet port. So what you can do is, in case if you are making this as a proper wired router along with Wi-Fi, hotspot, something like that, then what you can do is you can use one USB to Ethernet adapter, or you can also buy some other x86 device with multiple Ethernet ports and use that as your OpenWRT build device. And since anyway you are doing OpenWRT, you can also play around with pfSense as well, and this gives an idea how you can build yourself a highly capable Wi-Fi routers by yourself at home. Okay, so but again, saying that this is no means a comparison between this and a proper Wi-Fi routers what you get, because the reason is these contains a very tiny MediaTek processor, a very few MBs of RAM, etc. But the whole advantage what you get is its power consumption. This consumes around 10 watts or something like that. I have measured, but I am not sure at this point of time. So it consumes around 10 watts or something when it is idle, or bit less as well. When it is in the load, somewhere like 20 plus watts. Whereas these devices, you can hook it up to a small Wi-Fi router UPS, and it is not going to consume much power. So you can see here, you can search router UPS. So you can use any of these 9 volts or 12 volts router UPS. Strangely, long back when I bought a Xiaomi router, it came with 5 volts PSU. So in that case you need 5 volts, but most routers will accept either 9 volts or 12 volts. You can see here. So this has an advantage. It is very lightweight and it is just enough for that job. But in case if you are an expert, if you are willing to become an expert in OpenWRT and you want to explore, either buy something like this. You can buy something like this because it is x86. As I said, you can use it for other purposes, or otherwise you can use even Raspberry Pi as well. Even I have built Raspberry Pi OpenWRT for some research and stuff. So if you are wondering, I have started working in OpenWRT long ago. You can see here I have covered various episodes on OpenWRT in the past. And some of the episodes are very old, it's even 5 years old and stuff like that. So you can see here, and this is my Dragino OpenWRT device. It's from a customer, and this is even much older device, but I covered this video around 5 years back, but this is around, by that time it is around 8 or 9 years old device it is. And you can see this is another x86 device which I bought it for my Traffic Squeezer or Toffee project. And you can see the other OpenWRT devices. OpenWRT is something I was introduced something like around 2015. I was working on my Traffic Squeezer at that point of time. I mean, I was most of the times full time contributing towards the same, and then I got some offer to port Traffic Squeezer into the OpenWRT based device. So at that time I was newly exposed to OpenWRT. Luckily I am not doing any kernel build or anything at that time. I just did the kernel port etc. But the build, everything is given to me by a senior developer, but I am just a consultant. I was doing that work. So that's the first time ever I started getting hands on onto OpenWRT, and I was in and out exploring its features and all, and I understood, okay, this is meant for so and so thing. So this is my journey. And then again sometime around 3-4 years back, again I was working on another VPN project, and there I was using V10 etc. and I was using SQLite as a part of maintaining the metadata inside the OpenWRT and stuff. So again, these are things again I'm going to explain in the upcoming topics. Okay, so for now we just stick to this part. Is all about my journey into OpenWRT. Started like this. I'm not a OpenWRT OS build guy. See, here you have two options as a part of your career. If you are an embedded guy versus if you are a core OpenWRT guy who is into OpenWRT the customization, the other part of the OpenWRT when it comes to once it is installed everything, and then you need to install something, customize something, install drivers and stuff like that. You can go this direction, or you can be an embedded OpenWRT build guy. So the build guy is a different role altogether. He will do the customization, and then he will, in case the company have any proprietary software, is going to build it in that. So that is one part, one path you can take. The other path you can take is generally you can be a OpenWRT expert, where you can customize once the build guy gives you the OS. Okay, so there are two things. One thing is the build guy should give the OS. The other thing is OpenWRT developer once the OpenWRT is available to you. So there are two options. Okay, so you can choose either of them, or you can choose both of them. Depends on your career path and depends on the opportunity you get from that company. You can see there is an intro. What is that? You can see, you can read about it extensively. There is lot and lots of information you get. There's a lot of help you get with respect to OpenWRT configuration, parameters and stuff. Literally whatever you want, you will get it from the website, and of course from general websites as well. So you can see here. So here you should be able to find, for example, this D-Link router. Okay, you can always search D-Link. You can enter any specific model, and you can see there is some sort of OpenWRT port, and some discussion will be there always. Okay, DIR 615, say for instance 615 OpenWRT. You can type, and you can see there is a dedicated page about it. Usually what they discuss is all the routers will have this LEDs, right? So to show the status and all. So those things are connected via GPIO pins, and they will document which pin corresponds to what, and how it has been set, and how that entire customization is done, and all other specs, and a custom OpenWRT port for that device. This is not to be confused with official port, official thing, firmware what you get from D-Link. That will have all the D-Link components, but this is like a basic port for that specific router hardware. So you can see here, Yeah, you can see here all different releases available, and then you can find all this other information as well, various variants, various specs. You can see the RAM, how much it is, the flash memory, how much it is, things like that. So where the firmware is stored and where is that, what is the RAM capacity is, and also this chip, okay, the processor or SoC which it is used in that board. Okay, you can see here, and you can see lots and lots of information, and then you can see here how the LAN ports have been configured. So strange thing about this cheap routers are, so when I say cheap routers, don't assume they are not capable. I am saying cheap routers means these are not enterprise routers like Cisco routers or something. Okay, so that's a complete different league. As I said earlier, the data plane over there happens in the hardware, versus the Cisco IOS just does the control plane part of it. Okay, it just controls it, nothing happens in the software layer, versus here the data plane is in the software layer. So the bargain what we get out of this is the router you get is cheap, but you get the risk of getting hanged or something like that in case some packet arrives in the kernel and then something crashes, something hangs. Okay, so that is the risk you take when you have this sort of architecture, versus there it is completely different. So I can illustrate in this way. So an enterprise router, you will have a complete Linux or Cisco IOS. Let's assume instead of Cisco IOS, let's assume it is a Linux kernel, and then you have the custom switch hardware or routing hardware. That routing hardware will have various Ethernet ports. Let's assume, okay, in the world of switching it is called a switch core. The processor is called a switch core processor. So this is what it is, and this will be somehow, it will be interfaced, you know, to the main SoC. Okay, this is your main SoC or your CPU, where you get Linux or some OS is running over there, and this is your switch or switch core. Let's assume it is a huge managed switch, okay, or it is some sort of a router, okay, router chip. So this is something like this. So usually this will be Broadcom, Marvell or some brand usually, okay, or some sort of a brand it will be. So they will have some way, it will interface with the kernel, and with the drivers, with the typical device drivers, you should able to control that. So this acts like your control plane. So this is your control plane, this is your data plane. So hope you can understand. With this architecture, let's assume this is your packets. Okay, the packets will arrive here, gets processed here, and it will be sent out. It will arrive here, get processed, and it will be sent out, but it will never arrive to this router. So to control this, you may have one Ethernet port here, and this Ethernet port is what they call it as a console port. Okay, you can set any local IP address like this 1.3 something like this, or usually it will be 10.0.0.1 something like that. Okay, some sort of factory installed, factory set IP address will be there, which you can change, and this will be connected to your admin network, where an administrator can sit there, access it. He will get a UI, and then he can control that, the basic chip core. But no packets, service packets will come to this SoC based board. Okay, it will never come here and it will get processed. Okay, it is only meant to administrate this switch core chip. So all the service packets will go like this. So this is how happens in an enterprise grade hardware, versus these cheap routers. Usually that is not the case. In this case, this is your Wi-Fi router, and in this case this is your enterprise router or switch. By the way, even this device, if you have OpenWRT port, even this device you can make as a managed switch. Okay, that nothing stops you. You can actually configure and make it into a managed switch. You can set VLANs, GLANs, everything, and you can really make it into a managed switch. But that disadvantage, as I said, is the packets will be processed in this in the software layer or within the Linux kernel. Okay, so let's now put the kernel here. So this is your kernel. So this is your kernel. In this case, it is coming via OpenWRT. Let's assume. Okay, this is your kernel. So below is your device driver. So let's assume it has some 3-4 Ethernet ports, and below is your device drivers. So what happens is, of course you have the entire IPv4 networking stack or the networking subsystem. You have the networking subsystem, and then above that you have this UI or CLI, etc. Right? So you will have some sort of UI. You can access the router, and then you can configure its stuff. So you have the typical UI over there in the user space. Okay, so you can see here, this is the networking subsystem. So whenever a packet comes, it will come here, it will get processed here, it will get out of this device. So this is what happens, but usually this is not the architecture you get from these cheap routers. Usually what they do is, they will have some sort of a managed switch here, and strangely that managed switch is having this 4 ports. Okay, and that managed switch have only one Ethernet port behind. Okay, ETH0 or something, and only that is exposed to the OS. Okay, means Linux kernel, only that is exposed to the Linux kernel, and it will get this sort of 4 ports. And what they put LAN port, WAN port is just it's just a gimmick. I mean, it's just a plastic molding. You get this blue color means it is WAN port, this yellow colors means LAN ports, nothing like that. Usually you can configure any ports into anything. So if you want, say the company D-Link is giving, this is your WAN port, this is your WAN or internet port, and these are your LAN ports. Nothing like that. In case you have the complete OpenWRT and you can log in and do stuff, you can actually make multiple WAN ports. So you can make this into 2 WAN ports, say for instance WAN 1, WAN 2, and then this is your LAN port, something like that. So this is your managed switch. Okay, this is your managed switch. So something like that, like this it will be there, and it is quite easy to do, and I can later show you in this video how those things are handled. Okay, so hope you got an idea. So in this architecture, this becomes your control plane, this becomes your data plane, and this becomes as usual, this becomes your control plane. And you can see here, data plane is also software layer, control plane is also software layer. The only downside is if there is some packets are coming and getting processed, and in case if the kernel crashes, your entire router will halt. Okay, hence it's quite often you may find these routers at times may hang. You don't enable fancy features in these tiny routers like QoS, etc. It's just a gimmick. They offer such features but don't enable them. At times the router is not capable. Okay, in case you live in a summer, hot summer or hot weather places, at times the router may get overheated. And one more downside is these plastic body routers will get quite hot. So you should avoid setting any fancy features in these routers, which may overheat the SoC, and it may crash the routers at times. So randomly you may find the router is crashed and it is not able to connect your devices to the internet. So this is a common reason, because you are enabling something which is the router is not able to handle it. Okay, I mean, just the manufacturer provides it, TP-Link or somebody may provide, but doesn't mean that you need to enable. The reason is I am saying it with respect to my own personal experience. I had the Xiaomi router, which I have even did one teardown somewhere here. Yeah, you can see here I did a teardown. This router is a classic example. When I enable some QoS or something, after some 6-7 hours, once in a while it will randomly crash, and again I need to do a hard reset, pull the power cable and put it back, and then it starts working again. After 3-4 hours or maybe one day later it may crash again. I need to do that, but the moment I disable the QoS etc., then it will start working fine. The reason is, you can see here the kernel is doing the data plane work, hence it is like that. Okay, so hence these are normal Wi-Fi home routers for general domestic use. Okay, home routers for general domestic use. Okay. This is what is the architecture. Doesn't mean even if it is some sort of serious sd-wan router or something like that, still they may have the similar architecture. Okay, as long as they use OpenWRT and stuff, it is going to be the same. Okay, so this is what it is, versus this is an enterprise router or switch. In this case you can see it's a dedicated hardware. This is a dedicated hardware. Okay, and all you have is, as a part of control plane, you have this software layer, and so this is your software layer, which is your control plane. Okay, this is your software layer, which is your control plane. Let me put it this way. So this red box is your software layer or your control plane. So in this way, none of the service packets comes to this SOC, hence there is no question of crashing something. In case if this SOC crashes because of the operating system, still this will work independently, and of course you may not able to configure or log into its CLI or UI or something like that, but still you should able to use the router which is deployed in some data center in a rack. Okay, so yes, you can wait some time and you can do a scheduled downtime, and then at that point of time you can pull the power cable and put it back, or do some sort of reset cycles, hardware reset cycles. But in the case of emergency, while it is in service, you don't need to struggle like in the case of these Wi-Fi routers. Okay, this can go down anytime and it may stop entirely working, even the service packets as well. Means you should not able to connect to Wi-Fi, you can't communicate from LAN to internet, none of those things are possible. LAN means wired LAN to internet, none of those things are possible in case of routers like this, because the data plane and control plane, everything is in the same software layer, versus in an enterprise switch. Okay, even in an enterprise device, nothing stops you using any OpenWRT as a part of control plane. So you should understand that as well. So again, going back to this, hope now you got an idea. You get different hardware from various SOC options. You get MediaTek processor and stuff like that. Again, I'm going to cover them down the lane. Okay, so you can see whatever you buy in the market, you get some ports like this and a Wi-Fi antenna and options like this, which is completely customizable. If you can make it as a Wi-Fi hotspot, and one of these ports as WAN port and rest as LAN ports, or if you want multi-WAN router, then you can also configure couple of these ports. You can borrow it and make them into WAN ports and few ports into LAN ports. Okay, so that's what, because what you get is a sort of a managed switch. It is not technically 3-4 ports which are extended to the Linux kernel, or this SOC is exposing to the kernel. In the case of this does not have anything like this. So any amount of Ethernet ports you connect, it's going to be like, directly these ports are exposed to this kernel. But in case if you buy any router like this, usually it is just one port split into multiple ones, and each of this usually you can assume this is like ETH 0.0 and this is ETH 0.1, like that. It's a VLAN ports. So inside the OpenWRT you get tagged packets, outside you get normal packets. So that's what happens. 0.2 and this is ETH 0.3. Since in this case we are making these two into a single LAN port, usually what happens is this will be let me do this way. So in this case it is not this, in this case it is, say it is this, it is this. Like this you can configure the entire LAN, you can configure into one VLAN ID, okay, something like that you can do that. So this is what it is. So I'll explain, as I said, I'll explain this further later, okay. So hope you got an idea about the whole big picture of OpenWRT, the whole objective, okay, and then what is the big picture of these routers, how OpenWRT is relevant. Any of these routers, it can be any form factor, like this, like this, like this, like this, like this, all these contains OpenWRT. Some will allow some sort of limited login, etc. Some very cheap routers you buy, they may not even restrict, you can just log in and then you can play around. Some expensive ones, of course, they will completely lock the end users to do such things, okay. So even these kind of geo routers also will be nothing but OpenWRT, and you don't believe, even sometimes you may get this dongle. Actually, I have seen in one interesting case, Airtel 4G dongle. Yeah, this dongle, okay, this dongle is an entire router. It's not just some USB adapter, LT USB adapter, it's an entire router. So this dongle, the moment you plug in, it's like an entire router with 4G, and then this USB port emulates a Ethernet port, okay. So this dongle is such an interesting device. The moment you plug in, it will emulate an Ethernet port. You will get an entire Ethernet, new port here with its IP address and stuff. So that will be your internet connection, okay. So that's what it is. But again, this is an entire OpenWRT on a single dongle, okay. It's an entire SoC in that way. So one side is 4G, one side is USB Ethernet, okay. So that's what it is. So hope you got a big picture. So let's move on to the next topic of exploring this hardware itself. And before that, I can do one thing is, see, this is the Zebronics SSD it came with. They just installed some custom SSD like this, a cheap SSD, which is fine for the price which I got. You can see, as I said, RAM alone I have upgraded, and this is what it came with. So what we do is we download OpenWRT image, and then we quickly flash, and in the OpenWRT images again you got lots of things to learn, which I can quickly cover. If you go to this download, and then you get all this information, you get the basic download page, table of hardware. You can click this. See, now comes the question, who puts these images? If there are generic x86 and generic processors, you will be getting them. Sometimes if it is any custom device, the manufacturer itself may release it. So anyway, as of now we go to this stable builds. These are generic OpenWRT stable builds. You can see various versions available. The most recent one is something like July, then September, you can see there. So we go to this 23055, and you can see targets. You can see all the options you get, okay. You can see some Broadcom chips, you can see here. Next you can see this is yeah, these are the MediaTek processors and Realtek processors and ROC chip. In fact, I have covered a ROC chip OpenWRT of a small ROC chip board I have. You can see here, okay. You can also watch this episode. I am going to link the relevant video episodes so that you can go through the same. So you can see there, that is there. So in our case, it's a generic x86 64-bit. It's a modern x86. The reason is, if you click x86, you get these options: generic, legacy, and stuff like that, and then 64. So hence, I'm not using the word generic, because generic x86 is, I assume it is 32-bit. Legacy is that old Pentium processor based. So 64-bit is this thing qualifies. This is a modern system. It's a small form factor system. It's just a SFF PC, okay, small form factor, yeah, SFF PC. It's a form factor is called SFF PC because this is not any micro tower or some sort of form factor like that. This is a proper, I mean to say mini ATX, micro ATX. It's not that form factor. It is more like SFF form factor. So it's a with full capable Intel processor. So that's why we go to this 64, and again you get lot of options. Sometimes if you are not sure about, you can do always a Google search OpenWRT x86 generic versus legacy. You can type and you should able to find that information. See what they meant. Yeah, generic is for 32-bit only hardware versus legacy is this is Pentium 4 or old type of hardware, Pentium MMX and stuff like that. So in this case, this is a modern one. So hence we choose that. The next thing is the release variants, squash FS and then ext4 and stuff. So again you can go and search about OpenWRT squash FS versus ext4. And you can see the differences are squash FS is a read-only file system, so it will be taking less space versus ext4 is like a proper Linux install. Okay. The another interesting thing is at times you can use squash FS and you can install. The moment you do first time boot, it will ask you to extend it to the entire hard disk. Then you can extend and install it in the entire hard disk and stuff like that. You can do something like that and you can extract. Similarly, it is only kernel alone and or the root FS is the only the file system alone, but not the entire bootable image. So you can see various options. So ever anytime if you pick any options in terms of getting the image for your device, you can pick either this ext4 combined EFI, which is Wi-Fi boot, or otherwise this legacy BIOS boot. Okay, you can use this one or this one for ext4 variant, or otherwise you can use squash FS. The one more thing I thought of telling in the beginning, I forgot, is see, unlike Ubuntu, the whole footprint of OpenWRT is so minimal. Every app what you get is so minimal. The kernel itself is so minimal, extremely lightweight. You can see the specs of these kind of XOCs. It's very small. So the entire build with all capable options as a router build should be available. Hence it's highly optimized, highly miniaturized embedded Linux distributions versus a full-fledged OS like even Ubuntu server. You can take even Ubuntu server, make into something like this, a full-fledged Wi-Fi router, but the problem is you have to do hell a lot of work in terms of its customization. But OpenWRT is tailor-made, readily available, something you can take as it is and then do minimal customization and get it up and working. So that way you can see you have these release variants. Okay. And as I was telling this part, this manage switch, in fact you can take any MediaTek say some sort of processor or SoC data sheet. See, you can see here this is a Firefly hardware, and they are using this what I am looking for is base website, firefly.com. Yeah, we click English and you can see there they have also some boards, router boards like that. Core boards, development kits, servers. What we look is products. Yeah, mini PCs, edge computing, development kits. Otherwise we can directly search Firefly router board. We should able to get something, yeah, something like this. You can see here. Okay, yeah, single board computers and also this very tiny router boards which you can use for OpenWRT, and you can also search a router board and you get various brands. You can see here, okay. Even this you can buy and then build yourself a custom router or some edge compute device, and you can see that it has many ports, even it has this SFF and stuff like that. Yeah, something like that. You can see even Amazon has this MikroTik board. You can buy any of these options. Yeah, especially this Banana Pi or something. It has various router boards. You can even go to their main website and you can go through, and they will give you official OpenWRT port of those boards. So you can see here Banana Pi 4. See, the main advantage of this versus something you buy a Wi-Fi router is it's a very powerful device which you can configure, and you can customize, configure and stuff. That is why when you get a job into network embedded software developer or something like that, or embedded build guy, either you be a software developer or just a build guy, in either of the cases what happens is you will be given some sort of a board where you can customize, and you should be able to see these are very capable, unlike those cheap Wi-Fi routers over there. In this case you can see it has even SIM ports, and it has this SFP ports as well, and then regular Ethernet ports. So in this case you can make this into a highly capable multi-WAN LTE capable router. You can see here you can connect 4G 4G WAN ports, I mean LTE ports. You can see here it is accepting SIM cards, and then it is accepting this SD card slot where you can install the OpenWRT image, where you can flash the OpenWRT image, and then you have this options. So you can customize whatever you want. You can make these two ports as WAN ports, or you can make this into one LAN port, WAN port, and similarly these ports you can configure whichever way you want. The company may give you an OpenWRT port in a specific way, which again you can customize it. So in this case they are saying this is WAN port, LAN ports, and 3 LAN ports, 1 WAN port. This SFP port, 1 is LAN port, 1 is WAN port, but you can customize whichever way you want. You can see it also accepts this it also accepts this some will accept this SSD cards. You can see here it accepts this M.2 SSD as well, and then it is accepting multiple slots for Wi-Fi modules and stuff. Okay, you can see here. So such options you get. You can do some DIY, and you can build highly capable edge devices with this. Okay, and you can see here hardware specifications, and this is you can go to the software download, and then you should able to find the company provided OpenWRT port. Okay, similarly you can find various other stuff. Okay, port download. So they may provide a OpenWRT download within their website for that Banana Pi. Yeah, you can see there. Yeah. So go back, go to their website. Yes, and they may provide 2-3 links. One you can download from their website, one you can go to from website to OpenWRT and download from OpenWRT website as well. So you can see here. So this is a different board, and again they may have an official OpenWRT port. Okay, you can see here official OpenWRT port, which you can download, flash it, and start using it. Okay, you can see here. So such options are available, endless possibilities. And let's suppose we take one of this MediaTek. I randomly typed MediaTek. You can see here one of the SoC spec it popped up, and you can see its data sheet. And when you go through the data sheet, as I said here, you can see usually these cheap boards will have inbuilt managed Ethernet switch module, where these exposed Ethernet ports will be there, but they are not to be confused as NIC cards. It is just a single NIC card which is connected to this managed switch, and that managed switch is exposing those 5 Ethernet ports, which usually manufacturers provides you as 4 LAN ports and 1 WAN port. So you can see here. So that is what is that, and you can read further about its specs and stuff like that. You can see here. Right, so this is what it is, and that's what exactly I put over here. So inside it is just one port. It is split into multiple ports with the help of this managed switch. So internally OpenWRT uses this VLANs. So in OpenWRT, back to this releases, you can see, so these are the options. In this course, what I am going to do is I am going to download this ext4 combined. This is a legacy boot stuff. So hopefully this should work. Let me try it, and we see if it boots and works fine. If not, we see what else can be done. Okay, so let me download this OpenWRT. Yes, let me download this, and then so we got it here. This is a GZ image. So we extract gunzip OpenWRT. Yeah, so you can see there it extracted into an image, which is again fairly small, 120 MB. Okay, so if you take 16 GB SD card, you know, sometimes that is more than enough for any OpenWRT installed on these kind of, you know, boards. Actually, you don't need extensive specs for that, you know, SSD or you know, to install this or flash this OS. So we install next we install this I mean we flash it onto this. I connect to this SATA to USB adapter. Let me connect it over here, and what we can do is we can run Belena Etcher. Okay. Target is this Zebronics 256 GB SSD. Select, and then we can flash. Yeah, since it was an unusually large drive, it shows this warning compared to the image size, which is still fine. You can say yes, I am sure. Yeah, you can see that it quickly flashed. In case if you are using any SD card, it may take some time. Okay, so which is done, and now I can remove this hardware. Okay, so it is done, and what I do is I take this out, and then now what I am going to do is I am going to cover about this hardware itself, its internal specs and Wi-Fi module, etc., etc., and then we can install this into this. So as you can see, this is that Dell 7050 Optiplex small form factor mini PC. So you can see here it comes with interesting front facing you know, audio port, and you can see you know, type C USB and then regular USB ports here, and then back side again it has these USB ports, and then the display port and the power supply, and it comes with one Ethernet port which you can use it for any as a WAN port or LAN port or anything. So in case if you want multiple Ethernet ports, you can populate these USB ports as well. So generally I can do that, but at this point of time I am just more using this as a laptop rather than a router. So as this episode is about building OpenWRT, you know, you can try using this ports as, you know, multiple LAN or WAN ports. So luckily, since I have this USB 3 to gigabit Ethernet adapter, I can use this as well. Okay, I can plug in one of these USB ports, and now it has multiple Ethernet ports. And as I said, of course, you can buy some sort of banana pie or some router board, or sometimes you may have that provided by your employer itself as a part of your project. So in this case, as a part of demonstration, I am doing this. I can prefer this as my LAN port and this as my WAN port. once it is booted up and once we start our configuration. Sometimes it may not work out of box. In that case, you need to install those relevant drivers. You need to go to this LuCI interface. You need to go to its UI, which is called as LuCI Interface, and then you can install those relevant drivers, which is tricky, but you can able to do that. So let's open this box. So it comes somewhat like this. So I have installed this huge crucial SSD so that I can use it. As I said, this intention of buying this is to use like a laptop, which is perfectly capable. So let me do a quick walkthrough. I can pull this out, SSD out, something like this. Yeah, something like this, and you can see here. And this is its Wi-Fi module, and the processor is beneath this heat sink, and then this attached fan unit, and then this has a small tiny speaker as well. So at times you don't connect any headphones, you can use this speaker itself for some sort of minimal audio output. You watch any couple of YouTube videos or something, this speaker is more than enough. It sounds more like a mobile phone kind of quality, okay, some sort of a cheap mobile phone sound quality, which is okay for certain emergency purposes. So you can see here, you can install an M.2 SSD as well. They have given a provision, you can see here, over here. And this is, as I said, this is the Wi-Fi module, and you can see the antenna is connected to this module. Okay, you can see the antenna, and the antenna cable is going all the way, and it is connected to this module. Okay, so this module, what they provided is it's a Intel, it's an Intel 8265 NGW. Okay, it's an Intel, yeah, 8265 NGW. You should able to see something like this. Okay, so this is the wireless module. Okay, so that's what it is, and it has 2 RAM slots. I can take this unit, and you should able to see here. So it has 2 RAM slots. One, it came with 8 GB RAM. This is the other one which I bought and installed, and beneath this heatsink is the main processor, and I believe the graphics GPU is inbuilt with the same processor module. Okay. And what we can use is, since I flashed the OpenWRT image, we can use this SSD. I don't want to mount it, as I need to remove all this pegs over here. So I can straight away plug this in. I mean, before that, of course, I can connect this back. So this is the heatsink, and they have done a very good job. You can see it's very easy to service, very easy to clean. In fact, just before shooting this video, I did a quick vacuum clean as well. So you can see here, you can do this, and you can just insert it. Should be fine. Yeah, you can see here, it pulls the air in the front and expels it back, almost like a server. Okay, so then we install this SSD. Beneath this SSD, I'll insert some sort of cardboard so that it can rest over there. Since it's not any hard disk or something, we don't need to worry about any vibrations and stuff. Okay, so I'm just installing this SSD, and it will rest over this cardboard stuff. Since one is not sufficient, I can cut it into 2 parts, and let me put it over here. Yeah, now it is perfectly fine. You can see here, it just rests over here. Now you can cover this case, and you can see the back side of the case looks like this, and this is the power button. When you press, it goes and activates this micro switch. So it's fairly done nice. Yes, it's a refurbished device. I thought, let me take a risk for 9,000 or 10,000 rupees. It's not a big deal. Okay. So let me just put this cover back. Yeah. See, you can have an option even to lock this unit in case of any security purposes, and then you can also use this Kensington lock as well. So you can connect, you can just secure this on a desk of any sort of office like receptionist use, since this is what its intended use is. Of course, you can secure this with this thumb screw, which I am not going to do. So you can see here. So this is what it is. I am going to share the link in case you are interested. You can explore buying something like this. As I said, this is actually a 7050 Dell 7050, and what I ordered is 7040. So technically, I got an upgrade. The older one has two regular USB ports, and this one has this USB Type-C type of port in the front. So that's one noticeable change I found quickly. I thought they sent something else. Then again, I checked this variant. So you can see here I just hooked up the OpenWRT device, and this is the Ethernet cable connected to the switch, which in turn connects to the internet. And you can see this one I'm not using it for now. And then you can see the display port and the power supply cable. So we can do a quick power up here. Since I can't do a screen capture, I need to do is I need to move this whole thing somewhere below so that it is connected, and also I can populate the other LAN port to the PC. So one cable I connected to my switch, through which it gets internet. The other cable I can connect it to the PC. It has another NIC card to which it will get the LAN port access, through which it can connect to the internet as well. So the Wi-Fi we can configure as a hotspot, and then we can start testing it out with the smartphone. So this is what is the agenda. We can quickly power it on. So I can switch my keyboard mouse to this OpenWRT device. So you can see here the display shows OpenWRT here. Let me point this out. Okay, you can see here it shows OpenWRT. So let me boot the same. So once it properly boots, it will show the OpenWRT icon. See, one advantage is connecting any USB to Ethernet modules or something. You can connect at this point of time. In case any kernel drivers or something, you can do a quick check of the same rather than doing it in the future. So you can see here the prompt have come. Since unfortunately I can't show more than this, the best option to do is take it out and then connect it somewhere over there. Yeah. So it shows LAN port is 1.1 and nothing else is populated. Okay, so that is that port, I think it is using as a LAN port, the one which is the wired port or something like that. Yeah. So anyway, I will do a shutdown, power off. Yeah. Switch it back to my PC. Switch it back to my PC, and I can dismantle this whole stuff and then put it over here. So you can see here I connected here so that these cables are accessible. I can't connect the display and we can do an SSH. You can see here this cable is what connects to the switch, and then this cable, this USB to Ethernet adapter, this cable is connected to the PC. So which is nothing but this cable which goes and connects to this large PC. The PC also have two NIC cards, so it will get WAN connections from either of that option. So you can see here. So this way we can do, and we can boot the device. So I am connecting this power lead and booting the device. So it just started booting up. I hope so, because we have not connected the display. So you can see in my PC, you can see here one cable is connected to the network, which is 0.x. The other cable is connected to this OpenWRT device, but the challenge is the OpenWRT device should give a DHCP address. In case it doesn't give, then I have to connect back again here and then do some basic configuration. We just wait and see, or otherwise I can swap the LAN cable, the Ethernet cable in that, and it can choose one as LAN cable, LAN port, and the other as WAN port. Usually OpenWRT does that. I have done with Raspberry Pi as well. Okay, so we wait and see. See this port, yeah, LAN disconnect. Yeah, this TP link, usually it has method, I configure it as DHCP. Yeah, and we leave it on like that, and should be able to come. In case if it is not coming, there could be another reason. It could be the case that USB to Ethernet needs some driver installation, something like that, and we have to wait and see. Or it just cable is loose. Okay, so let me check. Yeah, cable is little loose. I have just inserted properly, and let's see if it comes up. Let me also do one thing. I can swap this cable. Yeah, you can see it got the IP address. So let me put the internet cable on the other port over here. So you can see here I swapped the LAN cable over here, and then the internet cable over here, which is actually connecting to a large switch over there. Okay, that is the switch, and this is the setup. So now we have the IP address, so which means LAN cable is successfully connected and we are getting an IP address, and we can do some couple of ping tests, and before that we can log in and check what is the status. Okay, so we go here and we log into the OpenWRT UI access. One 192.168.1.1. Sorry, 192.168.1.1. So we can check its default user and username and password. So the password is empty, so it is root, and we should leave this field empty. So initially when it boots, you can set its password, and you can see it shows all this hardware configuration parameters. You can see the processor, etc, etc. As I said, this is Dell Optiplex 7050, so it gets this specific processor. If you get it as per the Amazon specs 7040, you might get a different processor. So you can see there, and you can see it's installed RAM and other stuff. So that is what. And now the main thing is you can configure the DHCP part. You can configure mainly the network interfaces and stuff. So go to this interfaces, and you can see it has this LAN port. It doesn't have any WAN port. It could be that it's a driver should be installed or something like that. So let me do an add new interface. Add new interface. Device is ETH0. Yeah, it could be ETH0. Before that, I can also do one thing is first we do an SSH and see what is the way it is configured. So what you do is SSH root at let me increase the font size, 192.168.1.1. Yeah, let me do this. Yes. And you can see, since the root password is not set, it just logged in. Okay, you can also do one thing. We can set the root password. I can set it as v linux scanner. the Linux channel, save, yeah, dismiss, and now that warning should go off. Okay, now I can quit this and again relog in the Linux channel. You can see there password has been set, that warning have gone away. So if you do if config, you get this list, and by the look of it you can see only one port is listed. If you can do one more thing is brctl show. So it shows all the bridge ports. You can see in case you are new to this, I have covered extensive video episodes on that. I am going to add that video links so that you can have a look. Okay, so this is your kernel default Linux kernel bridging. You can see there it has created this bridge port called brlan, and it has hooked up this eth0, the one interface which it is connected this LAN port to that. So other port which has that USB to Ethernet interface is not configured. So this is the thing. So somehow we need to enable that, and next thing is it has no Wi-Fi thing enabled as well. So you can see here interfaces, it has no Wi-Fi enabled. Okay, you can go here and you can go to this system. The next thing is the OpenWRT. For instance, you have Ubuntu, you have this deb files, those are the package files. In the case of Red Hat or RHEL, you get this RPM files, those are the package files. In the case of OpenWRT package files, okay, so you can see there these are called as IPK files, and from command line you can use the command like ipkg or something like that, and you can install those packages via command line. Or I don't prefer you doing that, because sometimes you need to install any dependencies and stuff which is automatically taken care. Much easier way if you use a UI such as this LuCI interface. So you can see the command is ipkg or something like that, ipk install package install. So we need the command line via command line, yeah, opkg, yeah, it's called opkg. The files are IPK files. So opkg, you can see here it shows all these commands, opkg, update, upgrade, like that you can provide options. Okay, so again I request you to refrain this. You can do this in case you have any custom builds IPK files you are downloading, you can install that, which is perfectly fine. Otherwise what you can do is you go here and you go to the software, and it shows sort of list of installed ones. You can see here these are the list of installed packages. You can go here at times, you can search if there is any updates, it will update. You can go here, generally you can do is update list. Usually you are supposed to do that, then it will do like opkg update, just like apt update you do initially, and then apt upgrade you do in Ubuntu and Debian operating systems. So once you do this, it will refresh this list, and then you can install any custom packages and stuff. So one thing we need to see is the other Ethernet port, we need to see its drivers. In case it's not installed, we need to install. And also one more thing is this USB to Ethernet adapter or something we need to install. Currently what is happening is, since it has not got internet connectivity, it is showing this error. You can see here it is showing this error because it is not connected to internet. So in this case it is a challenging part, because now you need a driver to enable this. Okay, so there's a way to solve this. Let me see if I can still somehow add this new interface. Okay, device unspecified, let's say unspecified, expecting. I can do one more thing. You can do if config -a, it shows any hidden Ethernet ports which is not enabled by the kernel. Okay, -a, you can see it is not allowing it. So this is a tricky situation, because if I enable this as a WAN port, now that connection will go off, and you need to also install this Wi-Fi drivers as well. Since Wi-Fi drivers are not installed, it is not showing anything over here. So it is become sort of a circular dependency. So these situations is what you need some OpenWRT work expertise. The whole objective of this video is to cover all these aspects so that you can be capable of configuring such a thing. As I said, if you get a career, you have two branches. One is you can be a build guy and then build the whole thing based on that SoC or chipset, whatever you are developing. Second thing is, you can be, the next thing is somebody does that, and your work is to actually take the OpenWRT and do the configuration. And in case if the company is working in any way x86, you don't need to do any custom build image and all. You just need to take this and then start customizing it. But this is what the challenges you encounter. So there could be, the reason is since the USB to Ethernet driver or something is not enabled in the kernel. That is the reason it is not enabling this. So in this case we can't do much other than releasing this port out of this BRLAN and then making this port into a WAN port. But if I do that, I lose this connectivity to this as well. So we have to do in a careful, creative manner. Okay. So interfaces configure. You can see here it shows this ETH0. What else I can do? Bridge VLAN. Yeah, we can't do anything. We just need to release it, and then I'm going to do is I'm going to perhaps connect to that, and I'm going to do that, perhaps face the camera towards the monitor and see what can be done. There's another thing is, if you do that, you need to access only via command line. You can't do via UI as well. So it's a sort of challenging thing. So before that, I am going to walk through this OpenWRT configuration files. Usually you get it in etc config. You get these configuration files. So if you go to this Vim network, you can see here it is configured, and you can see the port added is as a part of this BRLAN. This ETH0 is added. You can see their list ports is ETH0. In case you want multiple ports, then you need to keep adding them in this list. ETH1, like that you can add multiple ports within the same zone. Okay, within the same zone. So in this case, you can see there they have created this bridge port and they have added this into that bridge port. So this tells, unlike Ubuntu, you never need to use any brctl commands and play around. It's all automated here. Just do that here. Everything is taken care by OpenWRT. This thing you can do via command line as well, or you can do via UI as well. Okay, you can do this configure and then you can release them. Then it is the same thing. But if I release, I'll get this connectivity, it will no longer work. Okay, so hence I'm not doing that. So this is one thing. Next thing is, you can go to this firewall and you can see here they have created the zones, LAN zone and WAN zone, etc. But the problem is there is no cable which is associated with the WAN port due to lack of drivers. So you can see here. So here we don't need to do anything. You can see here they have done this zoning. So zoning actually means, see, when you go here, when you go to interfaces, it shows this in red color, which means this is in the LAN zone. If you create ports associated with WAN zone, so they will appear in a pink or reddish pink color. So that's what it is. Okay, so you can see there. So hence what I will do is, I will log in, connect the device back over here, and then what we do is we go to this network and we remove this association and we create a new zone called WAN, and add the device over here. In fact, right away I can do that. We can add a new interface. Interface name is, we can provide as LAN. It should be DHCP client, because it is getting the DHCP address from a switch, or if you connect this router to your ISP, obviously ISP will provide the IP address details. So DHCP client, the device is unspecified because it is not having that thing. It is okay. So let me do this create device, leave it as of now like this, save, and you can see if you do this network, if you say save and apply, it should appear over there. So save and apply, cat network, it should appear here. So you can see there interface WAN, and then it has that option proto DHCP, okay, and then in this case interface LAN, it is option proto static, okay. So because it is providing this IP address in the range 192.168.1.x, okay, so that's what it is. So this we created, and somehow we need to move this guy to this, okay, that's all we are supposed to do. So I hope with this it is done. Yeah, I cannot release this. Yeah, you need definitely mouse, you need definitely a keyboard and display, okay. So let me exit this, let me power off this. So hope you can say I have connected back. Let me boot the device. I will get a proper keyboard access. Yeah. Yeah, you can see here it asks this OpenWRT option. See, I have a small USB KVM switch. I can switch between this PC or this hardware, okay. So it boots fine. Now we need to disassociate that ETH0 from that to WAN port, okay. So vim etc config network, and I can do one thing. I can face this camera or something towards this monitor. So hope you can see it comes up like this, okay. Now we need to disassociate from this list ports ETH0. We disassociate, and we need to add say this line we delete, vim list ports ETH0, and this line we can remove, or maybe we can set it as ETH1, okay. Although it's been set as ETH1, it's not going to work because it needs the configuration. Yeah, we do this, and we do LuCI commit. Usually to update these changes you need to do LuCI commit, LuCI apply, no, not that, LuCI commit, and you need to do network settings, an update of the network settings. LuCI commit network. So LuCI commit means it will update all the files in /etc config ls etc config. It will update all these files. LuCI commit network means it will do that alone. Usually there is another command like network apply, something like that. You can do that as well. Since I forgot, what you can optionally do is you can quickly do a restart of this device and hope it works fine. Okay, if config restart, sorry, if config and brctl show, you can see it has not yet disassociated. Okay, it's not done. So restart or reboot something. Yeah, so we restart and see that it's coming as WAN port. See, once it comes as WAN port, we can do SSH again via PC. See, you can see here OpenWRT, you can select. Yeah, if config cat etc config network if of is 0, yeah, I have not connected the cable. Let me connect this cable. See, this is why you can see whether the driver has been enabled with this -a option. Okay, you can see the driver is enabled, but if I give if config, it's not enabled in the this thing. I mean, it's not instantiated, so the cable is not connected. So if we connect this cable now, it should come up. Yeah, right. So you can see it should able to get the DHCP address. If of is 0, and I say zero down, is 0 up. Yeah. Hopefully we should be able to get this IP address over there. We can once again review this etc config network option proto DHCP. The thing is, if any other configuration to be given, I have to check. If it is not list ports, then it should be something else. Okay. Go to etc config firewall and so everything is set properly. One thing is we should able to get that thing up and work. Now if you give brctl show, you can see it is not showing no longer that BR LAN. Okay, so with that it is fine. So or else I need to add some other option. So we switch back quickly to the PC and see if there is any option available. Okay, so we connect back to the PC. We check OpenWRT sample etc config network, and we open this. One is official guide you will get from OpenWRT website. The other one is all this discussion forums and things like that. Yeah. With various settings, configuration, you can see here device is this, protocol is this, and stuff like that. So what I need to do is option device I need to set not as list ports. So we can try that. As of now, option device is ETH0. So instead of list port, option device ETH0, LuCI commit, LuCI network commit, LuCI commit network, I'm sorry. Yeah, something like that. And LuCI show, it shows generally all configuration. LuCI show network.wan, then it will show that details alone. I will later explain you how you can learn this LuCI metadata file configuration options and all. Okay, so if config ETH0 down, ETH0 up, config yeah, let me debug if anything cabling issue or something like that and get back. So I have not done anything, I just rebooted the device and it started picking up this IP. You can see here, so you can see here it just picked up this IP which is my LAN network over in this zone. Okay, it is 0.x and you can see there it is 137. So with this the WAN port is connected and it is working fine. Now we need to now that internet is connected, we need to now have to configure its other port, but the problem is you cannot access its WAN port from outside internet because due to the firewall setting usually it doesn't allow that. You need to enable that and then only you can do this SSH to that. So again, this is the reason it is pretty complicated, and this needs some expertise in order to get going. So I can do commands like opkg, update and things like that. That should work fine, but the problem is I can't do SSH to that port. opkg update, it should work fine. You can see here it is not throwing any errors, okay, unlike before. Okay, so that is fine. opkg upgrade, yeah, it doesn't have the option unlike this dep commands in Ubuntu. Okay, so that's what it is. Update, it works fine, it's just checking all the packages and all. Okay, it's fine. Now the next challenge is we need to get the other port working. So if config -a, you can still see ETH1 is not appearing, which again needs this driver support. So opkg, we can search online opkg, install this USB Ethernet driver, something related to that. So we can switch back to the PC. So if you have a laptop, it is quite easy. You can keep one laptop here and then you can work over here. In my case, that is not the situation, so I have to work like this. So install OpenWRT USB to Ethernet driver or something. USB to Ethernet driver. So list installed, it will show USB kmod core. So some of this has to be installed. I can write it down because I can't get this monitor access. It is install kmod USB -core and then USB storage. Okay, and then UHCA something USB 1.1 drivers install. So let me just install whatever it is. It's still fine. It quickly works once it is all in place. So kmod USB -UHCI and then I have to do insmod also. Okay, insmod. So install or insert the kernel module. Okay, CI HCD, and similarly I have to do insmod of USB core. So hope you can see here. So these things we have to do, and you can see here with LuCI it is quite easy since it is UI. And also he suggests this kmod fs ext4, so I can do that as well. So kmod fs ext4, hopefully it is already there because it is an ext4 file system. Okay, similarly kmod USB3. So let's see, we install these packages. Yeah, right. So we come here and then we install these packages. Okay, so kmod, opkj install kmod USB core. Yeah, it has installed. You can see there, as I said, it will download those IPK files like dep files or RPM files, USB kmod USB core, then this version etc x86-64 and IPK file. So if you do in Raspberry Pi, this will be different. If you do in some MediaTek processor, this will be different, and you can see there it has installed. And next we install the kmod USB UHCI. If it is already installed, it will ignore. Yeah, even this, it has been downloaded and installed, you can see there. And then you can see USB kmod USB3. Yeah, there is nothing called kmod USB3 or USB3, sorry. Yeah, you can see it has downloaded a couple of IPK files and it installed. And then let me do this fs-ext4 as well. Yeah, it has done something for that. And then we can do this insmod so you can see there these IPK files, and then you can see this. So next I can do this insmod UHCI hyphen HCD built-in module. USB core core. So it's not working. So in that case I can do a quick reboot and see what it does. Okay, let's see, reboot and see if it picks up that ext1 interface. Fine, if config -a, so it is not coming up. One thing is, I am not sure about that drivers. So there is a hack I can do is I can connect that to this PC and see its driver module numbers and specs. Okay, and then we can see what can be done about it. I have removed this USB to Ethernet adapter. In case you have some TP-Link or something, sometimes it can just pick up and it may work, but in this case it is quite tricky. So what I can do is I can run this kernel logs /var log kernel log, and we insert this here and we capture its module specs. Yeah, you see here it is yeah, you can see 88179, something like that. Okay, something like that is the module AX88179. We note it down. Yeah, you can see AX88179, AX88179. It's a USB 3.0 gigabit Ethernet adapter. So what we do is we check any OpenWRT driver module name of this. Kmod. You can see USB to Ethernet dongle. So USB net ASIX. So that's what somebody have suggested. So we note it down. Kmod hyphen USB net ASIX, and it has done, and yeah, that's what they suggested, and this other option also. So they have done kmod hyphen USB net hyphen AXIX hyphen AX88179. So we try these options. Yeah, we try these options and see. Okay, you don't need to do anything. If it is UI, you just type some 88179, it will autofill, and then you can install. So easy it is to do in LuCI. But here it's this challenge you need to take care. So anyway, let's just pull back and put it inside. So this. Right, so OPKG install kmod hyphen USB net hyphen ASIX. So it is not accepting. Then I try ASIX hyphen AX88179. It is not accepting this as well. Kmod USB net, kmod USB hyphen net ASIX. So it shows unknown package. I can show here. You can see it shows unknown package. So we need to see if its name is changed or something like that. Let me see if there is any search option in OPKG. Command grep search search something OPKG star 8817 star search OPKG info. So let me do a quick reboot and see if something has done. Okay, let me just see. Since I have done those USB module and all installation, at times it may just pop up and start working. Okay. and it's not coming up. I can temporarily connect this cable to this port and see if anything gets triggered. No. So let me quickly search. USB net ASIX. Yeah, you can see there like this. You can install any Realtek drivers and stuff like that. Not always you will find working drivers, and that is the whole intention of this video, to give you that experience. Okay, USB SX not working. Let me see if any suggestions we get. Adapter does not work. Package not available. See, these things I don't do often, even when I was doing the work. Once in a while you do, and then it starts working, and then you write some documentation somewhere and then you forget about it. So this is not something often always you need to do, hence we will never have an idea of what to be done. So let me see. So same post, OPKJ, this thing, sometimes you can download that IPK file also from OpenWRT site, but again it should match the exact kernel and all that. Okay, so gigabit driver. You can say even you can't find it in his distributions. Okay, uncomment line 1 of distfeeds.conf. So I think I forgot to go through this. Distfeeds.conf. So where this file is existing. Yeah, it is etc kg distfeeds.conf. So we comment that first line and we see whether it works. Vim etc conf etc opkg distfeeds.conf. Yeah, we comment this first line and then we try this opkg install kmod usb net asix -ax 88179. It still shows unknown package. Yeah, it still shows the same. I have to do some digging and then get back. Okay, so the file which they showed is something like this: dish feeds. The first line you can see I have commented packages. See, after commenting, they mention to provide OPKG update, just like what we do in Ubuntu as well, apt commands. So OPKG update. So after this, let me try this command once again. It's not working, so maybe ASIX cannot install package. Let me check. Yeah, I have commented, maybe I uncomment. Yeah, it works now. You can see the screenshot. Yeah, you can see there it is not working, and then again I have done this OPKG install, and then it started installing these packages. Okay, so all you need to do is, as they suggested, you have to comment and uncomment. I have commented, it started not working, and again I have uncommented. Surprisingly it is working fine. So after that, provide this OPKG update, and then you can do this installation. I have done this ASIX, it is working fine. Let me try this other one also, AX 88179. I'm sorry, AS AX 88179. Yeah, so you can see there now it is installing those packages fine. So, and you can see, I think it has picked up automatically for LAN port. If config, and you can see finally it starts working. So 1.x and it is now up and working fine. So this much it takes something like this to enable. So you can see this is not connected, the internet cable is connected here, so we get this internet access, and this we can connect to this LAN cable. So what I am going to do, again I am going to remove this and install below this desk under this PC, connect one cable to the switch, another cable to the PC. PC will get the LAN access of this router, which means PC will get two internet connections. Okay, one is via this box, one is via the switch. So I have connected back. We can try this SSH now, and hopefully it should able to provide the LAN access to this PC. Yeah, you can see there it is asking the password. So good news, the Linux channel. So if config, you can see there now both ports are enabled, and then we can also show this drctl show, and you can see instead of ETH0 now it is associated with ETH1, and it has two firewall zone, one is the LAN zone and the WAN zone. If you want further more WAN ports like a multi-WAN router, you can connect one more USB to Ethernet in this type of device and get another WAN port as well. So you can name that as WAN 2, something like that. So we log in to this the Linux channel update, the Linux channel update, and you can see there it's connected this way. You can see edit, and you can see to which port it has been connected. So dismiss, and then this one again edit, you can see it has connected to ETH0. Okay, so this way you can have a look. So we now have two ports, and we can also test internet access and all. What we can do is come back here. So this PC have now two internet access connected ports. I can reach via directly like this to the switch, and from there to my home router, or via this OpenWRT router. So I can do ping 192.168.1.1. I can ping OpenWRT. I can ping to my home router over there, which it is pinging, and then I can ping. I'm sorry, I need to do this 3.1 via which interface to this interface. So I need to force the ping only via this interface. So try this. So you can see the interface is working. So in either of the interfaces I should able to reach internet. See, if I ping to this, it should go via this as well. So hence you can force that ping via this, and now we can do google.com via that interface. You can see here I can reach internet via OpenWRT. Now the OpenWRT router device or hardware is working as it is intended. Okay, so that is a good news, and you can go here and you can see some real-time graphs and stuff like that. I can do this ping and you should able to see those graphs. You can select different interfaces, ETH0, ETH1. Okay, you can see like this, and you can see that various other things. So now is the main interesting thing. You can go to the software, and once again you can do this update list, which is nothing but OPKG update. So you can see now it is working fine. To make this work is what all these things have to be done. Okay, so you can see that it is working, and the advantage is if you have the software, as I said earlier, you never need to do all this googling stuff. You just tell the package name ASIX and it shows all these names, and then you can install it via command line quite easily. Since we can't get both WAN and LAN access, I have to do that way. Otherwise you can just do this way. If you have Raspberry Pi, again you get this similar situation, because Raspberry Pi have only one Ethernet port. You need to use some sort of USB to Ethernet adapter, and in case it is not working, then you need to repeat the same steps. So hope this video helps you in order to replicate those steps, but provided yours may be a different hardware, it may be some Realtek, if you buy TP-Link, I think they may use Realtek chip. If it is Realtek chip, search which is that module ID, and then you can use that module ID, kernel module. These K mods are nothing but kernel modules. Okay, you can see there. Suppose you want some sort of Samba server, you can see there, you get that Samba server, you can install here. You never need to fiddle around with command line options. I generally hate, because searching something in command line is extremely painful and it's cumbersome, time consuming. So next thing is we need to enable the Wi-Fi part. You can see there is no Wi-Fi thing enabled. So now I have to do is enable that Wi-Fi. Okay, so we go here again, software, we search enable OpenWRT Wi-Fi. Okay, and Wi-Fi port access. So in this case we need like a hotspot, so that I can able to connect my smartphone and stuff via that instead of my other router. Okay, so you can see here, you can see wireless. Let me cancel this. You can see we can come here and wireless. See, there are general things which has to be enabled to enable the wireless. One is host APD. You can see host APD itself is not enabled. So let me do in OpenWRT way. I am doing in Ubuntu way instead. Let me do in OpenWRT way what it needs to be installed. So wireless, how to install OpenWRT wireless Wi-Fi. It should be done from ground up, because we don't have any Wi-Fi stuff. So you can see host APD, install host APD. So they suggest host APD. So it is the same as Ubuntu stuff. So host APD we install. There are two variants, you can see basic and this. The main thing, objective of entire Linux distributions like OpenWRT is it's a highly compact embedded Linux OS. Hence in case you don't have enough space or something, you can use this lighter version, otherwise you can use this standard version. Since it's a huge x86 device, I am using this standard version. You can see when you install this, it will automatically pick up all this dependencies and stuff. That's the best thing about using the UI, because it gives all this information. So let's install this. As you can see, finally the host APT is installed. We can click dismiss. Yeah, and we should able to see the wireless configuration tab over here, which is it not yet coming. So we see what else it needs to be installed. So one is this. Yeah, next is the driver for that device, which is that Intel module, which I explained earlier. So it's an Intel 8265 NGW. I just noted down when I was shooting that part. So what you can do is you can do a search, and this is the main advantage of having this UI interface, where you don't need to do any manual search. 8265, and you can see there this firmware IW 8265 it shows. So Intel wireless 8265 firmware, we install this. In case if you have any yeah, it has installed. Yeah, in case if you have any Athros or some other Wi-Fi module, you can install that corresponding driver. Okay, you can go through the module name, module model or whatever it is, and then you can search and install. So hopefully it should come over here. So what we need to do is we can do one more restart and hope that wireless tab appears. And before that, let me see if anything has to be installed. So kmod, see in this example they are installing some sort of Athros driver, you can see here. And then after this nothing, it should appear. Okay, so host APT they installed, and host APT utils, yeah, we can install this host APT utils as well. Maybe software, although they are not recommending it, I just sometimes do that for my customer installation. Okay, so host APT, you can see here host APT mini, OpenSSL, and utils, full featured 802.x EAP radius, and command line utility. Optionally you can install this. Yeah, yeah, that's it. So sometimes when you search online, they may discuss about some old version of this OpenWRT. In this example you can see it's a quite old version versus what we have is a current, more recent one. You can see 23.x. Hence you may have little bit of UI differences. Okay, so that's what we do is we can go to this command line and do a reboot. So cat etc config slash, and you should able to see the wireless folder. It's not yet appearing, which is it is not appearing. Hence one thing I can do is we can do a quick reboot and see that it gets initialized. Yeah, we do that and go to this etc config, and hopefully that wireless, it should appear. It's not coming up, which means something is yet to be installed. Okay, so we go here, this is there. In the same manner, install and driver for the NIC card. Now you are able to see wireless, and reboot the router, install the packages, reboot the router, which we have done. Yeah, it is not yet coming up. Overview, login. Yeah, it is not yet coming up, so something else has to be installed yet. 8265. Yeah, you cannot search this way, you have to again do this update list, just like what we do in Ubuntu, as I discussed earlier. Dismiss. So Intel 8265, it is installed. Installed updates. In case you have any updates, usually if you click here, after few days it should appear. Okay, see, you can see here LuCI mod network, something it suggests as update. I can do this, and that in turn installs all these updated ones. I can install this. System interfaces. Yeah, it is not yet coming up. We see some other guide actually. How to install OpenWRT. Sometimes these steps is no longer applicable when you use some sort of OpenWRT for Raspberry Pi or something. They may configure it out of box, it should work. Okay, but you can see here it's good to learn these things, because if it is not set up out of box, then you are supposed to do that. Okay, in Raspberry Pi, hopefully if you flash OpenWRT in the SD card and if you boot out of the box, it should work. Okay, you don't need to install most of the times anything. Yeah, network wireless. The thing is, since it is not coming, obviously we can't do this UCI show wireless. There is no such file itself in that folder. UCI show wireless, you cannot do that because there is no such file. It should appear over there. So hence we should check here software. Let me see any other host APD to be installed. Contains basic full featured blah blah blah. Then this contains host APD common. It is also installed. OpenSSL. And moreover, see here now, if you do the search of this 88179, you can see here it shows here. So this is what we have done earlier by entering it manually via command line, versus you can see how easy it is in case it appears in this LuCI interface. You never need to search. I mean, you never need to do that sort of manual install. Okay. So coming back to this, how to host OpenWRT wireless is not LuCI, is not showing, wireless is missing. So something like this. Wi-Fi config. As you can see, it is not coming up. Dongle is plugged and driver loaded. So provided the driver also should load. Okay. We see Intel. So these are various Intel Wi-Fi module drivers, in which this 8265 is installed. Let me install this 7265 also. Sometimes it could be some sort of sub variant or something like that. Okay, it's better to install and do some trial and error. Right, we do this. Usually if you do this Wi-Fi config, first time it will create that configuration file as well, in case if the driver everything is up and working. ls mod, we can search 8265, sorry, grep. It's not coming up, and you can see here this USB net 88179 driver is instantiated. Okay, so this is up and working fine. So we try getting this. In case it is not coming up, then something like that, it needs some sort of serious workaround. Okay, we try our best as a part of this video demo. So let me do one more reboot and see if anything it addresses. See, optionally, if you have some sort of Wi-Fi dongle or something, you can also insert that and get it up and working. It's much easier. In case some sort of USB to Wi-Fi dongle, you can use that as well. Still it is not coming up. What I can do is I can search some dongle like that and we can do some quick experimentation if I can bring up. Okay, I have a very old D-Link and some sort of TP-Link stuff. Let me do a quick check and then we can get this thing up and working. So when I'm searching for the hardware, luckily I found the same. You can see here this is a very old D-Link USB to Wi-Fi adapter. It's bought sometime like 2009. This I bought for some Sony Vaio device or laptop. So this one is DWL-G122. DWL-G122. Let me note it down. And one more thing I can do is, like I did in the past, I can do sudo tail -f where log kernel logs, and we can note down its hardware module. Okay, yeah, so let me plug this in the PC. You can see here it shows it's a Realtek Ralink it shows, and it is RT73 USB, something like this. Okay, so RT73 USB, something like that is that module is set chip 2573, something like that. You can see here RT:2573, something like that. Okay, so hopefully this is the one. Let me disconnect and we can insert back here. Yeah, we can insert back, and then while searching also I found this USB to Ethernet wired adapter. This is a USB 2.0 to 100 Mbps Ethernet ports. So the one main advantage with this is it's old legacy hardware, unlike the one what I have. Possibly this I plug in as it is. It may work without much of the fuss which I did earlier. So chances are there. Anyway, we go back to this bringing up the Wi-Fi service. So let me plug. We search for the drivers. It is 2573, something like this. RT. Let me do this update list. Dismiss 2573. Yeah, you can see here Ralink Realtek 2573 firmware. So let me do the install. So we can now do a reboot and see, this time at least it comes. Wi-Fi config, ls etc config. Yeah, this time it came. You can see here. This time it came, but what I am looking for is the wireless interface here. Cat wireless etc config wireless. So nothing is there, but it will get populated as soon as you configure in the LuCI interface. So sudo reboot, and we see this time anything happens. See, one more advantage in OpenWRT, as you must have noticed, unlike Ubuntu or something, the boot up time is quite fast. It quickly boots, unlike the standard Ubuntu and other desktop or server operating systems, which is again expected because the kernel is so much fine tuned and so lightweight that it is well suited for any tiny hardware embedded devices to large systems as well. Yes. CD etc config, Wi-Fi config, cat wireless. So still it has not got anything populated. Let me log in and see that anything it does. Software, dismiss, host ATD, this is installed. I can remove the wireless file and again do this Wi-Fi config, cat Wi-Fi wireless. It's not coming up, so we see what can be done. So after a lot of debugging, I felt a few things I need to address. Also a couple of links helped me. See, you can see here they are suggesting IWFE and stuff like that. Commands are otherwise IWconfig, but nothing is showing up. And one thing is, it again depends on the module driver or module version you have and things like that. It's just not like quickly out of box it will work. Your hardware may be different, mine will be different. If I do something in this with some other Wi-Fi dongle, then it will have some other issue. Generally I suggest, instead of doing this way, you start with Raspberry Pi. I'm going in this way because this is much difficult and tougher and okay, the kind of it gives that big picture is different versus something you do with a simple Raspberry Pi. Everything, if it works out of box, then you don't need to customize, you don't need to configure OpenWRT. Hence I'm taking this as example rather than something like Raspberry Pi. So you can see a couple of things I was going through, and then there's also another thing, someone is suggesting some other stuff, and also I have checked some USB kernel modules and stuff, so generally to get to USB 2.2 support and all. So with all that trial, I can get finally this port, this tab working, and much before that you should be able to do commands like IW config. This should work, and in this you can see here WLAN 0 should be appearing. Okay, so these are prerequisites, even you get something out of that. Similarly, IW, the guy who suggested here, he said do this IWFE and stuff like that. So such commands, again, if there is a proper hardware enabled, because FE is nothing but hardware, so if a proper hardware is enabled, you get some output. So you can see here, it's again the discussion is about 8265 NGW. Okay, come down. He provided another command reg set. You can see here again you get and you get all this stuff. So these things should work only when the driver is working, otherwise nothing will work. So anyway, you can see here finally the wireless thing appears here. In this it shows couple of them, because the USB to Wi-Fi adapter is also connected. What I can do is I can shut down and then remove one of that card. That is why it is showing WLAN 0 and WLAN 1. So I am not sure which is which. Hopefully IWFE I should be able to segregate, and also you can see here it shows all these modes and stuff, which is helpful in order to do some sort of custom configuration. Okay, so we go here and we should be able to differentiate which is which. See, which is Intel and which is the other one, or otherwise one dumb thing to do is I can do is shut down or power off, and then I can remove that USB to Wi-Fi dongle. Yeah, it is down. I can start. See, other than that, you should also understand the big picture of this UCI, configuration files, where it's so versatile. It's like a database. It's like a type length value type of. It's like a CSV or TLV type. Storing the configuration options in this text format metadata. Okay. So you can see here if config, it comes up and cd etc config cat wireless. You can see here it has this thing populated. Okay. So we go back once again and we come here and click this wireless. You can see here it shows. I can do one thing is I move this file wireless to wireless 2 and do once again Wi-Fi config. It will create a fresh file. Okay, cat wireless. You can see here it has created the fresh file, and this Intel board has couple of modes, hence it is showing like this. So wireless, you can see here it is showing like this. Now we have to see, you can see device is not active because we have not enabled anything. Okay, this we can do edit, and you can see it is 5 gigahertz and versus this it's a it's 5 gigahertz. We can edit any of this. We can set the access point name, the Linux channel, and you can see there they have automatically combined with the LAN port in that BR LAN bridge. Okay, so you can see access point and the Linux channel Wi-Fi security. You can enable some password ESK. So enable anything like this. So I can provide the Linux channel, something like that. So this should be able to do the trick. Okay, save and apply. You should able to get that information in this file. See, you can see here this is the set password, this is the SSID, and you can see the other options. So now you should able to enable this because we have set the SSID details. So if it all works fine, if the driver works fine, it should be up and it should be working. Yeah, so it is showing like this. You can see the radio is something active and it shows something like that. Now we can take a smartphone and see whether it shows up over there. So after a lot of struggle, setting up the Wi-Fi in the x86 device, I have finally abandoned. See, there could be few reasons. Some of those Wi-Fi modules are not that compatible as an AP mode. This I had faced this issue sometime in the past as well. Some modules are fine, but some modules will have really tough time getting up. One advantage, as I said, with Raspberry Pi is since it comes with inbuilt Wi-Fi, usually the image, if you flash the OpenWRT image, it will get the Wi-Fi thing sorted out. The radio will come up, and then you need to set up that SSID and stuff. So that also been challenge with the Raspberry Pi as well, which I am going to discuss shortly. The next challenge is it has the same issue as the other one. In fact, you can see here in this case I have connected this USB 2.0 to 100 Mbps Ethernet adapter versus that one had USB 3.0 2 gigabit Ethernet adapter. So this way you will get this identical hardware setup just like that. But again, in this I had the same issue like x86. Here it used to come the WAN interface. Then I need to do the same steps what I have done in the x86, hence I am not repeating what I have done. So technically you need to do the same thing. In this case it's a different driver, it's called AX88772, that's the driver, ASIX-88772. so that's the driver. I have done the same steps, install this driver and swap this as WAN port so that I can connect the internet, and this will be its WAN port. So that's what it is, and this finally it works and I can do a quick demo. So I'm going to connect the same way as x86 and we can quickly do an SSH and the UI access of the same. As you can see here, I connected this Raspberry Pi device just like x86. I'm going to leave it over here and then we can do its SSH access the time when it starts booting. SSH root at 192.168.1.1. Yeah, it booted. Yes, you can see it's just booted. Union -r, this is the kernel version, and then cat proc info. You can see this is the Raspberry Pi SoC or the processor. So we access the LuCI interface 68, and now you can see the wireless popped up. See, in x86 there is another issue happened is when I was fiddling with drivers and stuff, what happened is it installed some sort of virtual hardware Wi-Fi port, something like that. Hence the Wi-Fi network is coming up, but I am unable to get it connected or it is not appearing in this smartphone at all. I have tested with 2-3 other options, still it is not appearing. So I felt there is some issue with the configuration and stuff. So in this case you can see this, just let me disconnect the existing one. You should able to see somewhat here. You should able to see this is the Raspberry Pi SSID which it is connected. So hope you can able to see this. Okay, so this is what it is connected, and the network, everything works fine. I can access YouTube and stuff. So I have disconnected mobile data. So you can see here it just works fine. Yeah, you can see it. Yeah, you can see here it just works fine. Yeah, so back to this LuCI access. You can see here the network interfaces, it has this 2 interfaces, and if I do this if config, it will be same as x86. You can see ETH0 is configured as a WAN port, and ETH1 is associated with BR-LAN, which means it is going to accept the LAN connectivity. So BRCTL show, you should able to see that association. This Phi0 AP0, it's not, I'm not sure, it's something Raspberry Pi created. I think that is the Wi-Fi port. You can see here Phi0-AP0. So that is some nomenclature which Raspberry Pi is using. So this thing, as you can see, it is sorted out. Now I can do like before. I can do ping, before that if config, and the second port or first port is connected to my wide network, second one is connected to Raspberry Pi, and you can see this is 0.x and it is 1.144. so I can do ping google.com -i 192.168.1.144 or sorry 1.1 -i, I can give here -i, and this is the port, and it should able to ping -i 1.1. I'm sorry, google.com. Yeah, it should able to ping. Similarly, if I do google.com via the other port, it should able to reach also. So you can see here it has two WAN connections. One is connected directly to the switch to my home Wi-Fi router. The other one is going via Raspberry Pi, and then it is connected to my switch, which again connects to my home Wi-Fi router. So this way you can see the routing works as well as Wi-Fi works. The main issue you have to consider even in Raspberry Pi is this combination of parameters. So if you change the mode into something else, then it will not appear again, and before that it will also show some sort of error here saying it is disabled. So even in Raspberry Pi, it took me around almost an hour to figure out and then get this thing working. I have searched everywhere, I didn't found anything. Then I was doing some trial and error, and then finally it got it working. So I can suggest one thing is, or I better explain as I said earlier, is you should learn properly this etc config UCI files, config files. So let's go to this etc config. You can see here these are the UCI config files. So UCI stands for OpenWRT UCI. So it stands for Unified Configuration Interface. As I said, this is the main advantage of using OpenWRT versus some conventional OS like Ubuntu server or anything like that, and making or trying to make that into a router. See, it's quite easy to make Ubuntu device into a router, provided if you use some data center server or something like that, and you can make it into a network appliance, heavy duty network appliance. It can do firewalling and various other stuff, or some sort of deep packet inspection and stuff like that. But it's extremely difficult to get this type of conveniency what you get it in OpenWRT. So you can see this stands for Unified Control Interface, and the LuCI is the UI for this. Okay, so these are the configuration files. As I said earlier, the main advantage is you can do some sort of get set value type interface. So cat wireless, you can see this is the settings I have done with LuCI, and this is the configuration file. So this is where it stores. So you can do a CP wireless, and I can take a backup, something like this, and then we can also see cat wireless. Say for example, you need to fetch this SSID, or you need to fetch something, then you can do UCI get, and you can do Wi-Fi interface. This some are like array type, some are not an array type. So let's take an easier example, cat network. In this we can play around. So UCI get WAN dot device, and UCI get network dot WAN dot device. You can see here ETH 0 it appears. So I can give a sort of example where you can create your own UCI files in case you want to store some custom metadata. So before that, again we jump back to this Wi-Fi stuff, cat wireless, and let's suppose if you change any of the settings, and by the way, you can see here my smartphone is connected to this, and it shows its status. You can see one device is connected over here. If you connect more devices, it is going to show the status over here. So what we can do is assume you edited, and this is the default setting it will be in case if you try to bring this Raspberry Pi Wi-Fi. The board what I have is Pi model 3 plus B. Okay, so save and apply, and the moment I do, you should able to see that it will say it is disabled. Okay, it will stay up, and after a while it will show the status as disabled, and you can see my smartphone no longer able to connect, and you can see it shows as disabled. And now the problem starts. No matter whichever settings you do, nothing is going to solve. It never works. Hence you need to see which is the working configuration, and you need to do lot of trial and error. and I can perhaps do the same thing with that x86 device as well, if it is something officially I am working for some company project or some R&D and stuff. But since the objective of this OpenWRT entire complete course, here it takes a lot of time and it is going out of topic, so I thought let me do a quick alternative so that I can show a demo. So you can see here, no matter which way you edit 5 gigahertz, it is not going to work. After you say save, it will save and apply. It will again try to enable, and then again it will try to it will show as disabled. You can see here it is currently doing that. After a while again it shows disabled actually. So this is the issue. So in that case, hence such tricky configurations, if you feel that you may lose the configuration and something, you can even do this diff of wireless versus wireless 2. You can see diff command is not there, and if you want you can install via command line. So let's do this update list. I'm sorry, not command line, via the LuCI UI. Diff utils. You can see here, you can install this, or maybe this BS diff, whatever it is. So dismiss. So once it is installed, you should be able to do, and you can see there the difference between this configuration versus that configuration. There is some mode changed, and after that it is not working. So you can restore the working configuration just like that, CT wireless 2 to wireless, and then you need to restart this service actually. Okay, you can also do via command line as well. Restart Wi-Fi service OpenWRT, command line. Yeah, some sort of restart Wi-Fi. Other quick way to do is obviously a device reboot. Okay. Yeah, if it is not possible, then it is better to do is a quick reboot, and it will restore. And you can see, similar to x86, I have configured this Wi-Fi setup. You can see here I set the mode as access point. Of course you have other options. In fact, you can make it as a client, and this you can connect to other Wi-Fi device and set it as WAN zone and stuff like that. Since it is not the scope of this video, I don't want to cover this other modes. I have done this in the past and it is an interesting setup. So it's a kind of niche setup, but other than that, you can see it's like a typical Wi-Fi access point, and the SSID I set as the Linux channel, you can see here, and it is associated with the LAN zone, which is why when you provide a BR LAN or bridge control show, it shows the association of this port to that LAN bridge. Okay, so then you can see there are various other modes and stuff like that, and this is where exactly it shines out, or it begs a reason why you should play around with custom OpenWRT, because these are the options you will never find in store-bought ready-made routers, Wi-Fi routers, home Wi-Fi routers like TP-Link, D-Link, and etc. Because that is meant for regular people. But here you can find various expert options and stuff like that, and you can see Wi-Fi security. You can choose other options in case you have any radius server setup and stuff like that. You can choose various options, and you can see the key set, Wi-Fi password is set, and then again you can see various other options you can set. You can also do advanced settings, and you can set any custom MAC address and stuff like that. Not there, over here, somewhere here you can see you can also set any custom MAC address and random MAC address and stuff like that, so that it can generate any random MAC address. Okay, so you can see here. and also you can configure or customize its power output and stuff like that. So you can play around, but do it with caution. In case you have some working configuration, as I said, take a backup of that UCI etc config file, then you can play around, and you can see it just works fine. So this is a working sample of the same, and once this is enabled, you should able to see these things up and working. If it is not enabled, or if there are any issues, like you saw earlier, if it shows disabled, it will not show these options. And okay, so hope you got an idea how to play around. So play safe, and if you find any issues, first go through the specs of that Wi-Fi module, see which modes are supported and what is not supported and stuff. It's not an easy thing. It needs some expertise and experience and knowledge, which even I lack. I got a couple of students who work in OpenWRT. I got even one of my beloved student, he works in HP, and he extensively works in OpenWRT, but other than that I am still a sort of newbie when it comes to OpenWRT. And here you can see my smartphone is connected to this Raspberry Pi router or this access point. Let me do a reboot and then see it gets restored back. So this gives you an idea how to play around with this UCI configuration files. It is extremely important, and trust me, I was working with a customer. At that time I was not that aware of this OpenWRT UCI config files, and at that time what I did is I used something like SQLite. SQLite is a lightweight database management system. Unlike a full-fledged MySQL, you can use something like that, and then you can store your configuration metadata. The customer have what I kept is I kept some proprietary metadata of that VPN stuff and all that, and I need to store somewhere and retrieve. Hence I use that SQLite framework. But you never need, if it is very tiny get set type of configuration, you can well use this UCI framework itself. So if you do this, yeah, it came up, and you should able to see the Wi-Fi service up and working again. Yeah, you can see it is up, and then from my smartphone we see if I can able to connect. Yeah, it is connected, and you can see it is connected, and you can see it shows the status as well. So hope you got an idea of how to play around. Be very careful with this Wi-Fi settings. If you don't get it anything working with any specific boards, go through all the spec sheets or data sheets of that module, and then see if there are any limitations, any country limitations and stuff. This is going to be the same even if you have any LTE modules also, 4G or 5G modules also. So this is very commonly you may get lot of work on this aspect itself, in case if you are working professionally in some organization. Okay, so if you are a student, be prepared to get such type of work. So going back to this config files, so let's take a simple example, say CP network to say XYZ. I do that. So let's assume this is your custom config file which you want to store something. So v in XYZ. So let's imagine config option config device. So you can do some sort of stuff like this. UCI configuration file config option. Yeah, you can do something like this. I'll show you. You can store like arrays or lists as well. It's at times it is a bit cumbersome. So cat LuCI Let me take something which is easy to understand. Okay, so yeah, anything. Let's say Vim XYZ. Let's say config device. Say option. Say we want to store some serial number, or we want to store something like that. Say something like that. Okay, some serial number, and we want to store some custom value. Say what I can call is say serial number and say model, something like that. Okay, say device model, say ABC, something like that, and you want to store some sort of proprietary information. So this is what this UCI config is intended for. And what they have done is they have nicely integrated, so that whenever you want to change any configuration file, either you can do command line or you can do via LuCI interface, and then you can update those settings, and there are backend routines which will update the backend tools. Okay, so UCI get UCI show XYZ, it shows them same way XYZ device dot model device model, it will show. For this you need to provide get UCI device dot, it is more configured like an array. What I want is I want a value like a single values. I mean, so whenever it shows this brackets, it means that it is more like an sort of an array. So UCI dot in fact I have covered an entire video episode on the same. Some time ago I have covered one episode, you can see here, about setting these configuration files. So what happens is at times I take like this niche topics. Sometimes people may not able to understand why I have taken that episode, and basically it may have lot of information, but nobody tends to watch some of these interesting episodes. So sample file FAPS kernel interfaces. Yeah, config metadata product architecture, you can see here I have shot an episode, and in fact I have covered about this same topic. One is SQL, you can use MySQL you can use, or SQLite 3 you can use, or this LuCI as well you can use. Okay, so you can see here you can do something like this. In this case the configuration file I am doing something like this. Let me show the file. Yeah, something like this, config system host name is this and stuff like that. So something like that. So we can use even same nomenclature. Vim XYZ config system option, and then the options. So UCI get XYZ dot system dot device model entry not found config system dot XYZ option serial number device model UCI show. To show the entire file you can do this UCI show. It shows all UCI files, UCI show dot XYZ, then it shows like this, and you can see there here it shows this way actually. So option host name, and the way I am doing this UCI get system dot host name. Okay, yeah, the file name is system xyz dot system dot serial number, something like that. At times you need to do UCI commit bc. It's still not supporting. System config. Yeah, you can see here it shows. Of course, you can give some sort of a name, and a lot of syntax options are available. Let's not go much in deeper. Okay, you can do this, and you can write any Perl, Python scripts, and then you can manipulate. You can do this. You can do this get serial number, and then you can also set this value. Say set equal to say 1, 2, 3, and then you can again get. You can see there it will show like this. One thing is this emulates more or less like a Cisco CLI. Whenever you do this get set, it only sets in the RAM. It doesn't stores or it doesn't write it on that flash or the storage. So in order to do that, suppose if you do this cat command xyz, you can see it is not yet changed this serial number. In order to do that, you need to always do, after you change, you need to do LuCI commit, and then you can see cat xyz, it has written onto this file. So this is how you can store these values and retrieve these values. You can even store huge lists and all. You can almost store like a database rows and stuff like that, which I don't want to go much in depth. In case if you are interested, maybe you can discuss or you can send your queries or post your queries in this YouTube comments below. So you can see there, this is how you can do, and similarly you can do this UCI set device xyz.xyz.device model equal to 111, something like this, and again you do cat xyz. It is not going to set, so UCI commit, and then UCI get. For get, you just need to provide the parameter name, and then it will fetches that value. You can see there. So this is how you can use this almost like a database management system, and this is lot convenient than the regular etc files you can get in Linux systems, because everything is going to be in some format. Some will be in JSON like format, some will be in some other format, some will be type length value, this value equal to that value equal to this. Everything will have its own format. Like Apache server, its config file will be different, MySQL it will be different, things like that. In the case of OpenWRT, this is the great thing about UCI. When I started the course, you remember I was discussing about the management switch, which you will find in this Wi-Fi routers. So typically you can Google about OpenWRT switch configuration. Currently I don't have the hardware board, or I could have shown a demo, something like that. Okay, I used to have, but right now I don't have it. Okay, you can see here like this, the ports are mapped, and in the UI, LuCI UI, you will get like this. You can set this in this UI itself, but usually what I do is I configure via command line. Usually I do vim network, and I configure via command line. I can define which switch ports to be assigned for what zone, like WAN what port, WAN 2 what port, LAN, and things like that. Okay, so like that you can assign zones, you can create new zones, stuff like that. So what I can do is I can add various links which you can refer, including a link about this, and hope this gives an entire big picture about OpenWRT. What is the purpose, how you can take it, make it usable, configure the same. In case if you find any challenges, how you can solve. Challenges are inevitable, you have to solve at any cost, and this is the reason in fact you may be getting hired as well. And now as a part of career you have multiple paths. One is embedded build guy, the other one is OpenWRT software developer. He may be doing more automation here, he may be writing scripts and coding and stuff like that, configuration, and or you may have even entire exclusive UI which is meant to not use this LuCI interface, but a complete proprietary device UI the company may do. So again, somebody may be working in OpenWRT as well as a custom UI. So these are the various career options, and how you can do this setup, how you can install packages. Sometimes you can directly get those IPK packages as well, and you can install with that OPKG command. Although I have not shown, you can just install IPK with OPKG command. You can do something like this: OPKG install, and then you can use that file name, which is just like a Debian deb file install. Okay, you can do this OPKG install, and you can install that IPK files. And the importance of using this LuCI interface, and not only that, if you want to enable any cron tab scripts etc., you can actually write it here. This is nothing but, you can see here, this is etc rc local. This is not cron, this is a startup script. So the moment router boots, anything you want to run, any scripts and stuff like that, you can enter here, or you can go here via command line cd etc cat rc 0 dot etc rc dot local. You can add over here. In case you add over here, you can come here and edit as well. So that's the convenience you get with UI LuCI interface. And same way you can enable cron, and then you can edit the cron scripts. You can see here scheduled task. This is nothing but cron tab. You can do via LuCI interface, or you can do cron tab minus Dell. Yeah, you can see here currently it is empty, hence it is not showing. So you can do via here as well. And other than that, in case if it has LED configuration, you can set it up over here. I have not much done. And the most other important thing is you can also do this firewalling stuff, various zones. Suppose you want to do SSH to the WAN port, you can enable, you can do via this interface, which again takes away somewhere else. So hence I don't want to cover it in this course series. Perhaps I can do some other extended course video where I can cover some of these advanced options. So you can do that port forwarding, traffic rules, NAT rules and stuff like that. You can see here, you can add any custom firewall policies and stuff. So suppose you want to drop all ICMP packets, don't accept any ICMP, don't accept ICMP in WAN port, you can do such things. So similarly, the DHCP configuration is here. The DHCP configuration you can also edit via this UCI config file as well. Directly you can edit over here. So with this, I would like to conclude this complete OpenWRT course. I hope you guys loved this episode, this long format episode, which I never did in Linux channel. In case if you have any queries, or you want to discuss something, or post your feedbacks, suggestions, post your feedback in YouTube comments. Give a like. In case if you like this video, share it with your friends and colleagues. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.